video we invited Simon from Linz. In the next few minutes we will talk about particle size distributions. Simon, please introduce yourself.
Hello, my name is Simon and I'm from the Johannes Kepler University Linz, and my research interest is the numerical modeling of turbulent industrial scale gas particle flows. This is particularly important for steel industry and its transition to carbon-free steel production. However, the raw ore usually exhibits a wide particle size distribution with a range from micrometer to millimeter particles.
Simon, why is it so hard to simulate materials with a wide particle size distribution?
Consider a bimodal particle distribution, which for example includes 100 micrometer fine and 1 millimeter coarse particles with 50 volume% each. This in turn implies that we have to track 1000 times more fine particles than coarse particles. If the fine particles are even smaller, this difference gets considerably larger and the computational effort for the numerical simulation considerably increases.
Yeah, and one way to address this problem is coarse graining. In this approach, multiple particles are grouped to clusters. However, reasonable rules for this clustering are needed. As a question to you, Simon, would it, for example, make sense to cluster always 10 particles?
The drawback of using the same coarse graining ratio for all particles is that the main problem is not solved. Considering the previous example, we still have to track 1000 times more parcels representing the fine fraction than for the coarse fraction. Furthermore, at larger coarse graining ratios, we might face the problem that the coarse fraction is solely represented by a few parcels, while the fine fraction is still statistically well defined.
One last question to you, Simon. What are alternatives to the DEM when modeling polydispersed granular materials, and how could those benefit from DEM-based simulations?
The main alternatives to DEM are either a continuous particle model approach such as MPPIC or a multifluid model where the individual size fractions are represented by a separate granular phase. These approaches do not resolve particle-particle collisions but incorporate their effects by a particle stress. Thus, these models may considerably benefit from highly resolved DEM simulations, which can be used to deduce comprehensive stress models for polydispersed materials.
Thanks for your time, Simon, and thanks to all of you for tuning in. See you next time.